Section 11.2 deals with integration by substitution. Just like I would normally do if we were having class face-to-face, I'm putting the theory behind what we're doing up on the screen, and then I'm going to teach this to you by way of example. So with that being said, let's look at our first example. So in this situation, notice it's definitely looking much more challenging than the ones we saw in section 11.1. So here's the deal. Normally, what we're going to be doing is finding the expression, if one exists, that's 1 degree greater than some other expression. And let's see why we want to determine that. So let's go ahead and let u be equal to the expression that's 1 degree greater than some other expression. And the next step after we've defined what u is equal to is to take the derivative of both sides. So the derivative of u is just 1 du, or just du. And the derivative of the right side with respect to x is 4x dx. So note that we now have a 4x here, like we did in the original, and a dx here, like we had in the original. So what can we do with this information? Well, here's what we're going to do. We're going to rewrite this entire integral in terms of u. So let's see if we can figure this out. 2x squared plus 1 is u. So let's write down the u there. And then this quantity, 2x squared plus 1, was being raised to the 7th power in our original. So let's do the same thing here. But again, we're rewriting it in terms of u. So this, in terms of x, is now u to the 7th in terms of u. And the final thing we have to do is just write this du. Why? Well, again, du is exactly the same as 4x dx. So we've accounted for everything in our original integral that was in terms of x, now in terms of u. So at this point, we go ahead and evaluate this integral. And so we do u to the 7 plus 1, which is 8, and then divide by that new exponent, and then we put the plus c. We're almost finished. At this point, we use substitution one more time, and we replace this u with what it's equal to. So our final answer would look like this. 2x squared plus 1, that's what u is really equal to in terms of x. That's all to the 8th power, all over 8, plus c. Our next example is very similar. Here again, we have an expression that's 1 degree greater than some other expression that makes up our entire integral. So with that being said, we are again going to let u be equal to that expression. Still can't draw 3. We're going to let u be equal to that expression that is exactly 1 degree greater than some other expression within that integral. The next thing is to take the derivative of both sides of this equation. So the derivative of u is going to be 1 du, or just du. The derivative of x cubed minus 3 is going to be 3x squared dx with respect to x. Now, note in this case, we have a 3 that is the coefficient of x squared. We don't want that 3 there, because in our original integral, we just have an x squared and that's it. Nothing's in front of this. It's just x squared times dx. So all we have to do to get rid of this 3 is divide both sides of this equation by 3. So what this means really is just 1/3 du is equal to x squared dx. Now we have exactly what we had in our original integral. So let's take this information and use it to rewrite this integral in terms of u. All right, so if you had to divide by a numerical value to get this expression to match your original and the original integral, all you're going to do is write this fraction, this number, whatever it is, in front of the integral symbol. You're going to do that every single time. Now, what do we have? Well, x squared dx is really in the numerator. So we're going to write du in the numerator. That's the same as du right here. And in the denominator, we had x cubed minus 3. Well, x cubed minus 3 is just u. So what does this mean? Well, here's what it means. You can rewrite this integral now in terms of u, if you need to, as this. Du over u is the same as 1 over u du. And remember, this is a special type. Remember, 1 over u, same as u to the negative 1. When you take the integral of that, it's a special case, you get what? You get the natural logarithm of the absolute value of u. That's what this is telling us. The indefinite integral of 1 over u with respect to u is going to result in this, the natural logarithm of the absolute value of u. That's just a special case of integration. The next thing we do, the final step, is to rewrite this as the natural logarithm of what? Well, u is really the same as x cubed minus 3, and then you put the plus c, and we are finished with our second example.